Hello, geometry students. Welcome to our first day of Unit 1. So today is just going to be a very basic, we're going to talk about vocabulary. So our target that we're going to do is that we're going to demonstrate the knowledge of core definitions including point, line, segment, ray, plane, and angle. All right, so we're going to start off with just some very basic vocabulary today. Go ahead and pause the video. I'll kind of try to bring everything into view here so you can see it. But I would pause the video right now and try to copy everything down that you see. Give yourself a minute to get it all down, and then I'll kind of talk through everything. It'll be a little bit better if you pause first and then write it all down, and then we'll kind of talk our way through it. All right, so our first definition has to do with a point, okay? So a point is exactly what it sounds like. It's just a dot. It occupies no space. There's no area, there's no volume, there's nothing like that. It's just a point, it's just a dot. We use a capital letter to talk about our point, and I've used the letter A to talk about this one. And when we refer to the point, we just say point A. Point A, point B, whatever it is, that's just what we're going to call it. All right? Our next vocab word is a line. So a line can be defined by the 2 points that it passes through. You need at least 2 points to make a line. You can have more than 2 points if you want, but again, you need at least 2 points to make this line. The 2 points we have in this particular one are the points A and B, and as you can see, the line extends forever in both directions. Goes forever to the left, goes forever to the right. As far as notation is concerned, you see it in purple right there. We use the 2 letters that we have to make our line, and we put a line over the top of them with arrows on each end. So this shows us that we're talking about a line and just reminds us that it goes forever in both directions. Something to note about a line as well is that I have this written as line AB. You could switch this around and call this line BA. That's totally fine. So again, the order is not necessarily important as far as which one goes first and which one goes second. All right, next up we've got a line segment. A line segment is a part of a line. So basically it's like I took that line that I just had in the previous one and I just chopped off a little piece of it. Notice that this line doesn't have arrows on the end of it. It starts at C and it ends at D. So a segment is what we call a finite, it has a finite length, okay? It has a definite starting point and a definite stopping point. A line goes forever in both directions. So the segment, on the other hand, does not do that. It just starts at C and ends at D. We can measure a line segment. You can't measure a line because a line never stops. You can't measure something that's never going to stop. But a line segment has a definite starting and stopping point, so you can find the length of something like this. As far as notation is concerned, we see our endpoints are C and D. So we write those letters C and D next to each other and we put a straight line on top of it. Notice that the line segment, as compared to the line on the left over there, it doesn't have any arrowheads on the left and the right. Again, this is showing us that it has a definite starting and stopping point. Similar to the line, if I wanted to switch the order of this and refer to this as line segment DC, that would be totally fine. Both of those would be acceptable for an answer. All right, and our next one is called a ray. A ray is a part of a line, a portion of a line that starts at a point and extends forever in a certain direction. So think of this as almost kind of like a combination between a line segment and a line. So we kind of took that line, we chopped part of it off. So we have an end point right there at E, but it goes forever past F, okay? So it definitely has a stopping point, stops right there at E, but it's going to go through F and extend forever in whatever direction we have here. Okay, so a ray has an endpoint, but it still doesn't have, it has an infinite measure. We can't measure this because it never stops. So looking at notation, right there in purple, I've got the letters E and F with the arrow, with the line with an arrow on top of it. Again, so notice that we've got this, it's kind of like the combination between the symbols for line and for line segment. So we have no arrowhead on the left right there, and we've got one arrowhead on the right. Okay, so no arrowhead on the left, and then we've got arrowhead on the right. So what this is saying here is obviously this ray starts at E, it passes through F and goes forever in that direction. Now I mentioned in the previous 2 for line and line segment that the order is not important, that I can switch those. This is not the case for a ray. I cannot switch this around and talk about. So for example, if I said, if I said FE like this, this would not be the exact same thing, because this is saying that this starts, this particular ray starts at F and then goes through E. That would start here and then go forever in this direction. Okay, so you can't switch the order of rays. Rays, the order is important. When I see that E underneath the part without an arrowhead, that tells me that E is the endpoint. All right, and our last vocab word here is going to be a plane. A plane is essentially just a two-dimensional figure that continues forever in every single direction. So again, just think of any sort of two-dimensional surface, like a piece of paper or a wall or a ceiling. But this is just kind of one that extends forever in every single direction. A plane is defined by 3 points. We say that are non-collinear, which basically means they're not together on the same line. What I mean by that is these 3 lines these 3 points that I have, G, H, and I can't draw a straight line through all 3 of those points. All right, so and then as far as notation is concerned, it is called as plane GHI. I need 3 letters, 3 points to name the plane. And if there's more than 3, again, we could pick all the points if we wanted to. We could just pick 3 of them, but you need at least 3 points in order to do this. All right, so again, that's just some kind of basic vocabulary. Other vocab we have listed on the right-hand side over here is this idea of a postulate. Postulate is a statement that is accepted to be true without proof. I like to call these common sense rules for geometry. So that is a postulate. The other one we have right here is this word collinear, and I just talked about this. So collinear means these are 3 or more points on a straight line. So for example, if I want to show you 3 lines that are 3 points that are collinear, if I called this X, I called this Y, and I'll call this one Z, I can draw a straight line through these 3 points. Okay, so these points we would say are collinear. All right, so at this point, what I want you guys to do is try this You Try Now on your own. Now, you got the answers at the bottom, but don't cheat. Don't take a look at that. Try to answer these 5 questions on your own, and then just pause the video right now and go ahead and try those on your own. We will do these tomorrow in class. All right, so I'm not going to come through and show you, walk through it. This will be part of what we're going to start class with. So pause the video, go ahead and try that You Try Now, and then we'll come back together in a minute. All right, so next we're going to talk about angles. An angle is formed by 2 rays with the same endpoint called a vertex. All right, so what that's going to look like, again, 2 rays, we've got an endpoint, and then it extends forever in one direction. Here's a second ray, and that's going to extend forever in that direction as well. So if I call this point A, I'll call this one right here B, and I'll call this one C. So the point, so again, the endpoint that they have in common right here, that's what's called the vertex. So B is the vertex of this angle right here. Now, as far as naming the angles, we can do this one of 2 ways. We can either name it by its vertex. So again, the vertex of this angle up here is B. So I can call this, I use this little crooked L right there, that's the symbol for angle. So I can call this angle B. Or I can use all 3 letters. If I use all 3 letters, the only thing that I can do this, really, there's 2 ways I can do this. I can call it angle ABC, or I can call it angle CBA. The thing that needs to happen here is, you notice how B is the second letter for both of these? Since B is the vertex has to be in the middle when I'm naming this. So both ABC and CBA are acceptable, but that letter B has to be in the middle. Now, one of the things, too, that's a little bit different when I'm talking about the measure of an angle. So if I want to talk about the measure of angle ABC right here, what I do is I put a little m in front of it like this. So if I want to say measure of angle ABC, I would write it like this. So if ABC, for example, was like 30 degrees, I would write the measure of angle ABC equals 30 degrees. So again, when talking about measure, all right, we put a little m in front of it like that. All right, so right here it says, you write out what M angle B means. All right, so as I'm sure you know, we have 4 different types of angles. The first type of angle we have is when an angle measures between 0 and 90 degrees. So bigger than 0, we can't have an angle that's 0, okay? But if it's less than 90 degrees, this is what we call an acute angle, okay? If we have an angle that's bigger than 90 degrees and less than 180 degrees, this is what we call an obtuse angle. Now, if we have an angle that's exactly 90 degrees, so right in the middle between acute and obtuse, that is what we call a right angle. And this last one here, maybe this is one we don't know. It's not one we really use a ton. But if I have an angle measure that's exactly 180 degrees, we call this a straight angle. All right, so those are our four main types of angles. Again, I'm pretty sure you've heard of acute, obtuse, and right angles before. Maybe you've heard of straight angles before, maybe we haven't. But that's the four main types we have. All right, so this last example here, we want to talk about the hands of a clock. Okay, so consider measuring from the hour hand to the minute hand. So if we're thinking about a clock right here, I'm going to draw my version of a clock, right? So we've got 12 up here, I've got 3, got a 6 on the bottom here, I've got a 9 over here. So if I'm going to draw in the hands of this clock at 3:07, the hour hand is going to be, you know, a little bit past the 3, and then the 7 would probably be right about here. All right, so this is going to be an example of an acute angle. Okay, so 3:07 is going to give me an acute angle. All right, now 3:30, be careful with this one, because when we think of 3:30, we think 30, it's pointing straight down here at the 6. That's where the long hand is going to go. Now, sometimes we'll be like, well, if 3 o'clock, the shorter hand is going to be pointing right here at the 3. And so some people will say, well, this is going to be a right angle. But think about that. At 3:30, the hour hand doesn't point exactly at the 3. It's actually going to be halfway between 3 and 4. So that's just something to consider. Oh, sorry. This is going to be something like this. This is going to be another example of an acute angle, okay? Because the hour hand moves every single time the minute hand moves, okay? And the only time that the hour hand is exactly on one of those numbers is when it's 3 o'clock or 4 o'clock or 5 o'clock. All right, next up, 3:45. So 3:45, again, the minute hand is going to point right there at the 9, so straight across there. And again, 3, again, it's not going to go straight across to the 3. So similar to the one we just did here, we're going to have 3. Again, a 4 is going to be somewhere right here. The hour hand is going to be pointing closer to the 4 than it is to the 3. So what we're looking at here is actually an obtuse angle. All right, next one, talking about 5 o'clock. So again, 5 o'clock is going to be, the 5 is going to be right around there. So at 5 o'clock, we are pointing exactly at the 12, and we're pointing exactly at the 5. It's really the only time the hour hand is ever pointing exactly at one of the numbers is exactly on the hour. Okay, so this appears to be an obtuse angle. And then last but not least here, we're going to do 5:58. So at 5:58, again, this hour hand is going to be pointing straight up at the 12, right almost at the 12, and then it's going to be right down here almost at that 6. So again, this is going to be another obtuse angle. All right, so that's it for the notes for today. I said, so if you have any questions, come to office hours, try that homework on your own, and we'll talk about some of these problems in class. Have a good day.